ANOVA, Analysis of Variance by Kelly Abbey and Stephanie Suddeth. If you're watching this presentation, you're probably wondering what is analysis of variance or ANOVA. Throughout this presentation, you will hear me refer to analysis of variance as its abbreviated name, ANOVA. In simple terms, it is a statistical method used to test differences between two or more means. It provides you the necessary understanding to determine if the results are significant and you should reject the null hypothesis. Remember, that is where no real difference occurs, and accept the alternative hypothesis, your hypothesis over your research. There are two types of ANOVA tests. The simplest kind is a simple or one-way ANOVA. This is where one variable is explored and has two or more levels. With the one-way, you cannot tell which specific group were different from each other, only that at least two groups were different. The other kind of ANOVA is a bit more complex. It is called the factorial or two-way ANOVA. This kind uses two or more variables with two or more factors, 2 by 2, 2 times 2, or 2 by 3, 2 times 3, etc. This allows for the exploration of how multiple independent variables affect change in the dependent variable. So now that you understand what an ANOVA is and the different kinds, you may be wondering when to use them. Let's start with the one-way. This kind of test should be used when there is a need to find the statistical difference between multiple group elements. In other words, the different means of those groups. A two-way ANOVA should be used when there is a need to find the statistical relationship of the two independent elements that make up the dependent variable. Are you confused yet? Let's take a look at some examples to clear up the doubts. A study conducted in 2014 wanted to learn which of three resin bonds was the strongest. They used a one-way ANOVA to compare the three groups. In this one-way ANOVA, we can see the results of the ANOVA. Let's break each part down for a better understanding before moving on to its finding about the strongest resin bond. The SSB represents a sum of squares between groups, which is the variation of group means from the total grain mean. And the mean of squares between groups, MSB, is subsequently obtained by dividing SSB with degrees of freedom. The SSW represents sum of squares within groups, which is the sum of squared deviations from the group means and individual observations because the equal variance in all the groups was already assumed. The mean of square within the group, MSW, is subsequently obtained by dividing SSW with degrees of freedom in the same way. The ratio of MSB and MSW determine the degree of how relatively greater the difference is between group means, between group variance, compared with group variance. If the ratio is greater than expected by chance, we may not think that all the group means are the same, which means that at least one mean is subsequently different. As the result is interpreted about the whole set of groups, it is called a global or overall test. The ratio of MSB and MSW is known to follow the F distribution. Therefore, to get a statistical conclusion, we may compare the F value calculated from the observed data with a critical value at an error level of 0.05 in the F table. Using ANOVA test, the research shows that C resin has the highest bond strength and A resin shows the lowest. That wasn't so hard, was it? Now let's take a look at the two-way ANOVA. The key to using the two-way analysis of variance ANOVA for this study was to find the relationship between two different groups of rabbits and discern if the use of propofol affected the left ventricle pressure, or LVP, of which group of rabbits. Both groups, the normal and the high cholesterol of rabbits, was given 25, 50, and 100 micrometers of propofol by infusion, and their LVNs were measured every 10 minutes for an hour. 3 rabbits made up each group of test subjects. As you can see from the chart, there's a high probability of interaction between heart type and dosage. The two-way ANOVA is figured just as the one-way ANOVA in the previous slides, but instead of one independent variable, there are multiple independent variables that affect the dependent variable. In this example, the dependent variable is the LVP measurement in rabbits and how the different doses of propofol will affect the normal or high cholesterol heart. With the p-value being less than 1, then this shows a direct correlation between H type and dosage on rabbit LVP. According to this chart, there is a direct correlation between rabbits' LVP with high cholesterol hearts. This is an important study since you can apply the test results to humans. ANOVA tests give researchers the ability to find statistic differences between single or multi-independent variables and their relationship with dependent variables.